Where are we likely to see multicollinearity? We tend to see it in time series data, in panel data, and in aggregate group level or ecological data. And I'm going to talk a little bit about these each individually. So time series data, this is where you have a single case that is observed at many points in time. So we might expect that there's going to be very little change in between measurement intervals. Allison gives the example of measuring the economy over a long period, so measuring it quarterly over a long period of time. We don't expect some values like unemployment, inflation, or gross national product to change rapidly from quarter to quarter. So essentially, there's multicollinearity in the variables, and that's connected to economic stability, right? So the more stable the economy is, the less those things change in large part over time from one quarter to another. And that stability means that what was going on a quarter ago is very, very highly correlated with what's happening now and what's happening in the following quarter, and so on. Panel data is another example where we often see multicollinearity. When people are part of a study over a long period of time, they tend to give, it's the same person, so they tend to give the same answers to similar or the same questions over time. So things may not change all that rapidly. If you ask somebody how they feel politically every time there's an election, you're asking the same person, you would expect to see consistency in those in that reporting. The problem is that consistency means that their answers are highly correlated with the answers that they gave previously. So panel data can create this kind of an issue. You might think of another example is if you ask a 40-year-old woman how many children she has, then ask her again when she's 45 and 50 and 55 and 60, we're going to expect that number to be the same, because by the time someone is 40, they have more or less reached sort of the end of childbearing. They're still involved in childbearing, but they're less likely to have additional children after that time. So we would expect the answers to that question to be the same or very close to the same moving forward. So we may see perfect collinearity among the responses to those questions, and it has to do with the time period in which we ask it. We can also see the issue in aggregate group level or ecological data, where the units of analysis here are groups of individuals and the variables are summary measures. So what happens is that the random variation among individual people tends to average out when they're combined into groups. And this can create multicollinearity in these types of measures. So if we're using the mean is taking all the data together. And so the individual variations are taken together and collectively have much less impact on the mean. And it's again one of those things where we'd expect the mean to change very little over time, although the individual cases that make up that mean may have a great deal of variation. But that gets lost when you deal with data at the aggregated or ecological level. What are some of the solutions to multicollinearity? Well, you can delete one or more of the variables from the model. There are problems associated with this because you're making a choice about which one to get rid of. It could have an independent impact that can't be taken into account because of the multicollinearity. There may be important reasons to leave both variables in. So deleting is often the choice that we make, but it may not be the best one. The second one is to combine the collinear variables into an index, and we'll actually talk a little bit moving in chapter 9 about what we do using factor analysis, and that's a way that we can deal with it by creating an index or looking at multiple dimensions of a variable or an indicator and taking them in sequence or taking them as a group. So we can combine them into an index as well. So instead of, we can create a latent variable model instead of creating an index that does kind of a similar thing. So we'll talk about where we see latent variable models later. We can perform a joint hypothesis test. So instead of looking at the test statistic and the p-values for each variable, we can actually test the joint hypothesis that none of the collinear variables has a coefficient different from 0. And this can be done in SPSS. This is an option that you can choose within modeling your multiple regressions. The only real solution is to increase sample size, which is usually not something you can actually do. The bigger your sample, the less of an issue this is going to be, because the bigger your sample, the smaller your standard error, right? So we're going to have less of this, less of the impact of multicollinear variables the larger our sample is. We're always limited in the sample size that we can have. We're limited by time, we're limited by resources, we're limited by funding. And so we can never have the size. We would always like to have a bigger sample than what we can gather for our data. But that is the perfect solution to dealing with multicollinearity, but it's usually not the practical solution. He also adds that you can use individual data instead of aggregate data, and you can use cross-sectional data instead of time series data, since both of those types of data are especially vulnerable to multicollinearity.